Hi, Layla. Welcome to Thursday. We're doing lessons 39 and 40. 39 is about multiplying decimal numbers. Last time, I think it was lesson 37, we talked about adding and subtracting, and the name of the game was lining them up. But now we're multiplying decimal numbers, and the rules are quite different. What we're going to do, well, let's just jump into example 1 for lesson 39. It's on page 204, but I'm going to write it here. When we're multiplying decimal numbers, we write them down in the same format as we're used to for multiplication. Try to keep my columns straight. And what we do with the decimals when we start multiplying is ignore them. Oh, that's fun, right? Just ignore them. Just ignore them. 7 times 5 is 35. We multiply as usual. Carry the 3. 7 times 2 is 14. Plus 3 more is 17. Carry the 1. Well, 7 times 0 is 0. Plus 1 is 1. Okay, so I've got the 7 done. That's all I need to do. There's no other numbers to multiply, just these zeros. I can ignore them. So we've done all the multiplying we need. Now what we do is pay it. There's nothing more to do, right? We're completed with this multiplication. Now we figure out the decimal part. And what we do is we go back to these two original numbers that we had that we multiplied together. We call them factors, but they're just the numbers that we multiplied together. And we look to see how many digits in the original numbers were behind the decimal, if you will. So to the right of the decimal. Well, in this first number, the 2 is behind the decimal and the 5 is behind the decimal. These are just my arrows reminding us to look at these two numbers. And look here, this one is also behind the decimal. So in the original number, there were a total of 1, 2, 3 numbers behind the decimal places. So what that means is that we have to put the same number of digits behind the decimal place in our answer. So we start counting from the right. We need 3, 1, 2, 3. That means the decimal place goes there. It doesn't matter that these are different numbers, that it was 2 here and 1 there. It's just the total of 3. 1, 2, 3. I spit on my page. Oops. If you would like to put the 0 there, you may, but this is our answer. It's absolutely fine with me if your answer has lines underneath it. I like that. Yay. Let's do another one. This one's fun because the way it's written looks confusing. It says simplify, and then it does this. What? What the heck? An exponent? In our decimal multiplication problems? All right, let the panic subside. And remember that this just means multiply this base number 2 times. So this is going to be the same as 2.5 times 2.5. That's our base, and we multiply it 2 times. 1, 2. Oh, well, that's different, isn't it? So I'm going to multiply this. I don't want to squish it down here, so let's go up here. So it is 2.5, and again, I don't want to write it landscape, if you will. I want it portrait style. So we can multiply. 5 times 5 is 25. 10 plus 2 is 12. Don't worry about the decimals. Now, we're multiplying this second place. I recognize this isn't 2, it's actually 20, so I put the 0 there. 2 times 5 is 10. Put down the 0, carry the 1. 5. Okay, keep my columns as best I can. I add it up. You know how you always add 5, 2, 6. Okay, we're all multiplied through. Now we do our decimal thing. We go back to the numbers. Again, I'm just drawing these arrows to remind us where to look. We count the number of digits that are behind a decimal. There's a decimal. There's one behind it. I like to underline. It makes it super easy to count, and then it makes it very easy to make sure that the number down here matches the number up there. 2 decimal places. We start at this end. We go 1, 2. I underline them. Notice we don't start counting from the 6. We count from the little side, not the big side, if that makes sense. So 6.25 is the answer to this multiplication problem. That's correct. Okay, so we start counting over here. Kind of makes sense because we're counting on the right side here, so we count on the right side there. 2 decimals, 2 digits behind the decimal, 2 digits behind the decimal. It does not matter that these are 1 each, and here we're putting 2 in one number. No, that doesn't matter. That's not wrong. It's just the total number that matters. Okay, one more, example 3. Multiply 1.6. Again, they write it out like this. No, that's not helpful. This is how we want it. 1.6 times 3. 3 times 6 is 18. 3 plus 1, 4. Beautiful. Just 1 digit behind the decimal place this time because the 3 doesn't have any decimals, so we know it's like that essentially, right? 1, so there's just 1, so it's 4.8. Dun, da, da, da. That's all that there is for lesson 39. I'm glancing at the practice set. They look super straightforward. Just remember, because there are a couple of these in the practice. If you get the exponent, don't worry. Just remember that that means multiply the number here 2 times itself, right? Beautiful. Okay, that's lesson 39. Let's go on and do lesson 40. And this lesson is a 2-parter. The first one is using 0 as a placeholder. We've already talked about that. Let's just try a couple problems where we might want a 0. So for the first one, it says subtract 0.5 minus 0.32. Okay, we know we don't like this format. We want this minus 0, and we have to line up the decimals. Okay, that looks really good, except there's a hole right there. As we have discussed, just go ahead and put a 0 in. That's perfectly fine. And then we can subtract. That becomes a 4. And that's the answer. If you would like to put the 0 here, you may. You don't have to. It's just a nice stylistic thing. Example 2. Subtract 3 minus 0.4. Okay, this is kind of like this one, but this number doesn't have a decimal. This 3 doesn't have a decimal. Well, let's give it one. Okay, let's rewrite it this way. 3 point, and I'm just going to leave it like that, minus 0.4. Okay, now we can see, yes, we definitely want the 0 there, don't we? Borrow, 10 minus 4 is 6. 2 minus 0 is 2. Bring down the decimal. Remember, in adding and subtracting, we line them up, but then we just copy it straight down into the answer. 2.6 is the correct answer. La, 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 la. All right. Example 3. Flipping on. Multiply 0.2 times 0.3. Okay, don't like your format. Want to do it this way. We're multiplying, so that means we ignore the decimal and put it in at the end. 3 times 2 is 6. 3 times 0 is 0. I mean, that's all. I don't even want to put that there. Let me copy this again and just do this in the most extreme manner. There's the 6. That's the only thing to multiply. Now we go back in and count. There's 1, 2 digits behind the decimal place. But look, this is a problem. There's only 1 digit. What do? Oh, well, we know we need 2 places behind the decimal. 1, 2, 1, 2, and we fill in with a 0. Makes sense? And you can leave the answer like this. You can't leave the answer like that. You have to fill in the digit behind the decimal place with a 0. You can put another one here stylistically. This one is your option. This one has to be there. All right. And then example 4. Use digits to write the decimal number. I said decimal. Decimal, not decibel. 12 thousandths. That tells you it's in fraction land. I'm going to get my places set up. That's 1/10. I'm making them super big just so it's easier. This is 1/1000ths. Okay, so this word matches to this place. 12 thousandths means that the 12 goes here, right? If I wrote it like this, that wouldn't be 12 thousandths, that would be 12 hundredths. In order to make it thousandths, I have to scooch it so it's lined up with the last non-zero digit in the thousandths place. So what goes here? You guessed it, a 0. So 12 thousandths, you can put the lead 0 if you want, but 0, 1, 2, 0, 1, 2. I just wrote it over. Make sense? Okay. The number that is spoken as the last place, that's where you put the last significant digit, is what we call it. And it means not 0. Okay, so the 12 has to be ending on the thousandths place. And that is our answer. Beautiful. So those are some examples of how zeros might be kind of kooky in all of this, but you can get them straightened out. And we've talked about some of those already. Okay, lesson 4, D. The last part of this is called circle graphs. Circle graphs are quite common in everyday life. Sometimes they're called pie graphs or pie charts because they look like slices of pie. And this is in the book. And I'm just going to copy it imprecisely. I'm on the top of page 210, example 5. Brett collected information from people in his neighborhood about their pets. He displayed the information about the pets in a circle graph. So here's how his graph looks. One half of the circle is one big piece, and it says dogs, 16. Then this is a quarter, isn't it? This is 1/4 of the whole circle. This is half. This is a 1/4. This says cats, 8. This says birds, 4. And look, this is another quarter, but this has been divided in half. Huh. Okay, and fish, 4. Now, this is a really great example of how I like my students to approach graphs. First, just look at it and see what you can figure out. Just reading it and looking at the shapes of things and just kind of taking it in. Don't worry about answering the questions right away. Just get a feel for what you're looking at. So what I see is, if you think of this as a pie or a piece of pie, dogs are half of it, aren't they? There's 16 of them. And then cats are half of that again, and then birds are half of that again, and half of that again. So I can see these all fit together really nicely. The fractions are gonna fit together really well. Okay, so let's go back to A. How many pets are represented in this graph? Okay, so we just have to add them all up. I'm gonna start and go around kind of clockwise like this. So the dogs are 16 plus 4 fish, plus 4 birds, plus 8 cats. This is 20. This is 12. That tells me it's 32 in all. That's just adding. There's 32 in all. B, what fraction of the pets are birds? Okay, if the total is 32, then I know that's going to be on the bottom of my fraction. And birds are 4. 4 out of the 32 total pets are birds. Cool. Can I reduce that? Yes. I'm going to divide it by 4 over 4. I just told you the answer. I'm so sorry. 4 divided by 4 is 1. 32 divided by 4 is 8. So 1/8 of the pets are birds. And C, what percent of the pets are dogs? Okay, let's do it. They want percent, but let's do it as a fraction first. 16 out of 32. You can kind of do it just by looking at it. But let's do it this way. Okay, let's reduce this fraction, 16 out of 32. 16 goes into both of these. 16 divided by 16 is 1. 32 divided by 16 is 2. 1/2. Okay, so what percent represents 1/2? Well, that would be 50 over 100 because percents always have 100 on the bottom and 50 is half of 100. So that makes sense. And that means 50%. That's kind of going the long way. And it works. It's mathematically accurate. But you might look at this and go, well, the dogs are half of the whole circle. Half is 50%. So you can just look at it and deduce that answer as well. But that's another way if that doesn't occur to you. Yay, we got all these right. Beautiful. Practice set. Okay, there's some filling in with zeros. Then there's one, I want you to be careful with this one, where it says, write the decimal number 10 and 11 thousandths. Make sure you name your decimal places 1/10, 100th, 1,000ths, and then put the 11 in so that it fills up to the thousandths place. You may need to stick a 0 in there. Look at what we did in this problem. And J, in the circle graph in example 5. So they're steering you back to this picture. What percent of the pets are cats? Okay. So you can use the information that we calculated that there are 32 pets in all and use that with the cats to come up with their percent. All right, beautiful. That's it. That's the 2 lessons for today. Good luck with your homework. I will see you soon. Farewell.